Welcome to the project demonstration of mileage projector in real time. So as you know that in real time petrol vehicles in two-wheelers, we don't have the mileage projection, means how much of petrol is left in your vehicle and with that how many kilometers we can travel. So this is going to be identified with our system. So for that we are taking two inputs. One is from the fuel gauge. So directly from the fuel gauge we are taking inputs, and that will be continuously monitored by our microcontroller. And also we need to know the how much of distance we have traveled. So then your system process is like, so there it will capture the initial how much of petrol was left, and while traveling if any liquid petrol was decreased, then for that decreased petrol level how much of distance the so-called vehicle traveled. So the distance will be achieved by this speedometer. We are using IR sensor at this sprocket. So from there we are going to calculate the travel distance, and we know the how much of petrol was consumed for that distance. So the distance by the liter in difference is nothing but the mileage, and how much of petrol was left in that. So that mileage into the left petrol. So we can get the distance to be traveled in further. So totally we are going to get the four readings: the fuel level left inside the tank, and the mileage, and the travel distance, and the remaining distance going to be traveled with the help of existing petrol inside the tanker. So it's going to the real time fuel gauge level. We are more controlled, interface to the microcontroller, and we are using 16:2 LCD screen. We have interface the fuel gauge sensor at A0 and A4 for this IR sensor, as we are using the timer pin to calculate the distance for every second counting. So here the calculation is like, so this is the main calculations. So so this is the pulsar bike teeth ratio. This is the engine teeth ratio 15 teeth, and the back wheel sprocket is 45 teeth. So the teeth ratio is 1:3, and the rotation ratio is 3:1. So whenever the sprocket wheel rotates 3 rotations, then 1 rotation will be covered at the rear wheel end. That's a direct rotation for the back wheel. So here the back wheel circumference from the pulsar bike, we got it 1.36 meters. That's a circumference, means one rotation the vehicle can cover the 1.36 meters. So as we know that 3 rotations is to 1. So now per rotation of the engine sprocket will cover 0.45 meters. So we know the distance per pulse, and we need to calculate the mileage equal to so-called distance by the liter in differences. So this is the main circuitry, as you can see on this LCD display. Now the right. So as of now the 3.9 liters existed, and we have previously calculated this so-called distance directly. And now let us see the by taking the petrol, and we'll check that by manually. So now we're taking the petrol out from the engine part, and there we can see the how much we will going to get the exact petrol level, how much we are going to get here. So we are using a Pulsar 2010 model for demonstration purpose. We have done some alterations for that. So as of now we have collected the liquid, so we can see the liquid level decreasing on our LCD screen. So the reading will be varies based on the fuel gauge movement inside this tanker. So see, if I move the tanker, the fuel gauge moves, and we can see the you can see the fluctuation also. So directly we are going to get the real-time readings from that. So you can see the petrol level is decreasing again now. Once it's settled, so we'll get the live readings. Right. So we have taken out the 1 liter petrol, and we'll pour it back. Set that. Right. Now let us go with final demonstration of. Now we will check the mileage projection along with distance calculations. So before on this we should know that. So now reset the system, and while demonstration we are not supposed to touch the motherboard as we are going to getting the earthing from that. And now before on that we should check this. So only one rotations the light should get switched on like this. Okay, so while demonstration one more thing is there, the external light should not fall on that. So by adjusting these IR sensors we can get the accurate signals. Right, now it is right, now it is perfect. After this one, now let us start that. So this one is the throttle for this accelerator. Right, now let us start the engine. This is the fifth gear one, and let us place it in first gear. We'll start it. Right, so as of now the travel distance is 2.1 kilometers. So the projected mileage is 27.3 kilometers per liter, and the remaining distance with this mileage, with this fuel, we can travel up to 1.2 kilometers. Here one more thing is there, we have other buzzer indication when the low fuel was detected. So then automatically we get the buzzer indication also. Let us see the buzzer. Alright, we have connected this buzzer at C3 pin. Now let us see. We are manually bending this to that side because the fuel gauge was placed this side. So when we bending that, as a fuel gauge comes down, and we can create the low fuel indication. So now bending. Right. So you can see that low fuel. And normal. So it's normal again. Right.